Hey everybody, how we doing? Dr. Jensen with CCJ3701 Research Methods in Criminology. So this week we're doing bivariate statistics, t-tests, ANOVAs, and correlations. So you may have noticed that we're starting to gear up and get more skills and take on some new topics. You now can do recoding, you can do conditions. You're going to learn a few more things you can do with data, and then you get to create variables and run statistics and then find out answers to questions, which is always fun. The reason we're doing all of this is because these are the exact same skills that you're going to be doing on your research paper. So you get to choose your variables, you get to run frequencies on them, see if that's what you want to use. You get to run statistical tests on them. You might have to recode them. You may have to do conditions. So I kind of load up your tool belt with everything you need before I turn you loose. So these are more statistics that we'll be running. So let's get familiar with them. So we're going to be going over, I'm going to move myself, different statistical procedures, t-tests, ANOVAs, and R, or we call it Pearson's R, correlation. Again, we'll also be reviewing some of the previous things from last week, as well as statistical and substantive significance. So remember, by way of review, whenever you're trying to determine what statistic to run, you have to know how the data are measured. If you don't, you're not going to know what to run. Okay, so you got to look at level of measurement and distribution of both predictor variable and outcome variable, or the independent dependent. Okay, and here's our famous chart from last week that shows you the kind of stuff we can run. So if we're looking at two variables, we want to see if they're related to each other, if they predict each other. This is what we use. So last week we were doing categorical style variables, nominals and ordinals. Remember, nominal is like a name category. Ordinal is the same thing, a category, but we can order it. We can run crosstabs and chi-squares on those kinds of variables. Okay. You can also run some other things. You see lambda in there, gamma, tau, Somers-D. Those are strength tests that you can run with it. We don't do those a ton, but you can. I'm not really choosing to do those right now because we're moving into some newer stuff, but those are other tests you can do. They're here for your reference if you want to know. Okay, but we're actually working on variables that have different properties. Interval ratio variables. So you see this IR in the corner. Interval ratio variables are quantities. Okay, they're not categories, they're quantities, numbers of things like income and time and how many, how much type stuff. So the big giveaway for bivariate techniques is the dependent variable a quantity? If it is, you're going to run a t-test, an ANOVA, or a correlation. Right there, that's it. Okay, so if it's a quantity, the dependent variable, you can run means tests, t-tests, ANOVAs. If you have two variables that are quantities, you can even run a correlation. Okay, but your independent variable can be whatever. It can be nominal, ordinal, or interval categories or quantities, doesn't really matter. But the dependent variable has to be a quantity. Okay, so make sure before you run any test that you analyze what you know. So you have to familiarize yourself with variables, run frequencies, crosstabs, look over the code book, know where the data came from, what it means. So you familiarize yourself with it and make sure that these variables or fields or measures are suitable for what you had in mind. So we're going to be down here doing the t-test and the ANOVA test, and we'll go into correlation soon. So t-tests. T-tests and ANOVAs are comparisons of the means. If you don't believe me, just ask SPSS. Where you go to navigate for this test is right here. So you go to the Analyze menu, and you go to the Compare Means part of the menu, okay? So that's literally what you're doing. You're comparing the means. This is where the t-test lives, independent samples, t-test, and this is where the ANOVA lives, the one-way ANOVA. So a little bit different menu you're going to be in this week, but that's where everything lives, the Compare Means menu, okay? All right. So here, we're going to use the t-test. Remember, the dependent variable is interval. But we use the t-test when the independent variable only has two categories. It doesn't matter if it's nominal or ordinal. If it's a comparison of two things, then we'll run the t-test. So that could be male versus female. Maybe you're comparing two different counties and some outcome across two counties. Or you're looking at people arrested versus people released and some effect that they may have. Okay? So that's a t-test. When it has three or more categories, that's an ANOVA. Pretty simple, right? So three or more categories. Maybe you're comparing ranks inside your agency, like lieutenant, sergeant, captain. Maybe you're comparing users of different drugs with how long they're staying in a probation program or a drug court program. Like time is a quantity. So you're comparing the heroin users versus the meth users, the cocaine users, the marijuana users. 3 or more categories, you're going to use the ANOVA. And remember, ANOVA stands for analysis of the variance, because there's a lot of variation in quantities, right? There's lots of different kinds of numbers people could provide with time or weight, space, income. So we want to look at all that variation. That's where the analysis of the variance comes from. We're analyzing all that variation to see if we can make predictions about it. That's it. So here's our little example. I'm going to move myself again. We use the t-test to know if the mean values, the averages of some variable, the dependent, are different for 2 groups. Okay? So we want to study, do men and women have different lengths of service when employed by the same institution, the military? So are men and women serving different amounts of time? Or in other words, does gender predict length of time served in the military? We think it does. We don't know, so we're going to go test it. Okay? Do our variables fit the t-test requirements? Yes. Sex is a dichotomous variable, meaning two categories, male, female. And time served is our dependent variable. We think the time served depends on your gender. Months in the military served, you can have any number of months. Okay, it's a quantity. So when you run the t-test, these are a few things that are helpful when you're in SPSS. Okay, so the t-test, again, is how you go to analyze. This is how you navigate to it. Compare the means, independent samples t-test. Once you pull that up, I'm going to put these variables back just so I can show you. You have 2 little places you can put variables in the window. So one says test variables, the other says grouping variable. Test variable is where the dependent variable goes, the quantity. Okay, so that's where that goes. Okay, whoop, I chose a variable I wasn't supposed to. Okay, the categorical variable, the independent, that's going to go in this grouping variable. Okay, so you pop that into grouping variable. Now you notice once you do that, you get this blue button that says define the groups. Click on that. All SPSS needs you to do is just tell them what are the values of the groups. Is it 1 and 0 or is it 1 and 2? Doesn't really matter where you put them. They just need you to type in the numbers that are assigned to those groups. Kind of a stupid, unnecessary step, but SPSS requires it. So you got to put those in, you click continue, and then you click OK. That's how you run a t-test in SPSS. Okay, but let's look at what the output looks like. So this is the kind of output you would get right here. So you would get a little descriptive statistics box that would say what the means are across those 2 groups. So let's look at that first. So here's gender, male, female, and then here is number of months served in the military. So for males, the average or the mean months served is 67.5. For females, it's 38.9 months served in the military. So for men, it's about, 5.5 years? For women, it's a little less than 4 years. And we had 67 men and 42 women. That's the N. That's our sample. So they appear to be different. We want to know if there's actually a statistically backed up difference. Okay, so we actually go down here for that answer. It turns out it is. So see this 0.008 underneath the sig area? That means it is statistically significant. So we have a less than 1% chance of being wrong, or a 99% chance of being right. So we can feel confident that this is a true relationship going on in the data. Knowing someone's gender can help us predict the average time they serve in the military. Okay, so that's it. Now you see all this other stuff down here. It says sum of squares, between groups, within groups, mean square, t. Those are all products of the equation. Usually in an introductory statistics class, you have to sit and calculate by hand the formula that goes into the t-test. I don't do that kind of stuff in this class because SPSS does it for us. And none of those things really get reported very much anyway because they're just products of the equation. So I'm never going to ask you for t or your sum of squares or anything like that. What I want to know is what were the descriptives, what were the means, and was it significant? Because ultimately that answers your question better than anything. Okay? So that is a t-test. So the t-test examines differences and means when we have 2 groups. But what if you have more? What do you run? You know this. You know it. You run the ANOVA. So now we're going to do an ANOVA example, okay? So we're going to do the same kind of an example. So you do an analysis of the variance in ANOVA. If you have differences between the scores or the quantities for more than two groups, you want to see how they vary from each other, okay? Just like a t-test, but it can handle more categories. So for example, what if we wanted to examine the same question, length of military service and race? Okay, so what if we want to see if there's a racial difference between how long people serve in the military? Well, the way you run an ANOVA is right here. So back in SPSS land, we go into Analyze, same place, compare the means, very bottom, one-way ANOVA. Once you launch that window, it's going to ask you for your variables that you want to test. So this one's a little easier to follow. It says dependent list. That's where your dependent variable goes, okay? So that's the quantity variable. So we would put the time served in months. The factor variable, factor is just a famous word for the independent variable. We use factor a lot for that. That's where your categorical variable goes. So that's where we would put race, because it has multiple racial categories inside it. The only other thing you have to do here is you need to ask for options and then ask for descriptive statistics. This is usually blank. Okay, you can even ask for a little graph if you want to, called a means plot, that shows you how they change. It's kind of fun. But you want those descriptive statistics. For some stupid reason, the guy that invented SPSS does not package these to come together when you get your output. So you have to ask for it. Okay, so ask for descriptives, click continue, then click OK. And you will get some output that looks like this. So here's our example for military and race. Okay, so here we have a similar kind of output, just like the t-test, but now we have racial groups. So it says white, black, other. Again, not an extensive list of racial groups, but for purposes of the example, it should be fine. So we have three groups, whites, blacks, and others. Here are the means of each group. Okay, so for whites, it was 8.5. For blacks, it was 14. For others, it was 9.2. And those are months served in the military. Okay, and these are the numbers of whites, blacks, and others that were tested. You don't have to worry about the numbers so much. Some people go, hey, how come, well, there's more whites tested. Isn't that going to throw off the results? No, these techniques actually account for differences in sizes of the groups, so you don't have to worry about that so much. Okay, so it appears there is a difference. We want to know if there is one. Okay, but they are kind of close together. They're only a few months apart. Okay, right here is our ANOVA table, and we get a little bit different statistics. We get an F statistic instead of a T. Okay, so we call that the F statistic actually. Significance level 0.177. That's too big. Okay, we need that to be closer to 0, so it meets our standard in social science. Okay, meaning we have a less than 5% or at least less than 1% chance of being wrong. That gives us, closer to a 10% chance of being wrong, almost 20% chance. So that's not good enough for social science. We say, well, there might be other factors influencing the result, but we should say it is not statistically significant. So in other words, there is no relationship between race and the average number of months someone serves in the military because it is not significant. Okay, we can't say the beyond chance that this relationship is actually true. So while there is a gender difference, there is not a race difference. But that's essentially the ANOVA. Pretty easy, right? So we're going to do part 2 of this lecture and show you a correlation in some law enforcement data that will be kind of cool to see. I'll also show you some of the other tests, and you can follow along in that video. We'll see you then.